All right, so today we're going to be talking about exponents, and this is a review. This is something that you really got in Algebra 1. But I'm going to be honest with you. When I was doing exponents, when I was y'all's age, man, I really got confused with the rules because sometimes you had to add the exponents together, sometimes you had to multiply the exponents together, sometimes you had to subtract, and honestly, I would confuse the rules. And the reason is because I really did not understand why you have to use an exponent or like what really you were doing when you were using an exponent. So I'm going to start out by answering, all right, why do we use exponents? Okay, and that's something maybe you had never thought of, but an exponent is really there to help you by just making it shorter for you to write. Because let's think about 2 to the 7th power. All right, so 2 to the 7th power really means we are taking the number 2 and we are multiplying it by itself 7 times. So you got 2 times 2 times 2 times 2, all right, 7 total times. So 1, 2, 3, 4, 5, 6. I need one more. All right, 7. So you have here it's 7 times that you are multiplying 2 by itself. Okay, so instead of writing out all that garbage right there, okay, we just choose that we can say, all right, you know what? The short way to write this, if I fully understand what an exponent means, is 2 to the 7th power. All right, it's the same thing here for x to the 5th. So a variable to the 5th power. You got x times x times x times x times x. Okay, and so this, again, this is 5 times. And here, x could be anything. X could be a 2, x could be a 3, x could be a 4. All right, so x could represent a bunch of different numbers. All right, and that's why we use a letter, because it doesn't necessarily mean that it's only a 2. It could be a 3, a 4. It could be a negative number. All right, and so we're going to use this idea of writing this out. That's going to help us figure out and kind of understand some of these rules and shortcuts. So I'm going to show you the long way around this, and that's going to expose or let you come up with the rule for these exponent problems. All right, so let's think about this problem here. I've got x to the 3rd power times x to the 5th power. All right, and so x to the 3rd power, let me use a different color right here. X to the 3rd power could be represented by x times x times x. So those are all my x to the 3rd powers. Okay, we're still multiplying here. And then in green, I'm going to do x to the 5th power. So you know we have 5 x's there. All right, so if I write this out and I see, all right, well, what's the short way that I could write this answer? The one that really makes this the most sense. Well, say I got 3 here, I got 5 total here, and that gives me a total of 8. All right, 8 times that I'm writing this out. And so the short way to write this would just be x to the 8th power, and that would be your final answer. That's the most simple way that it can be written. Okay, let's keep going. Let's think about the problem that we have down here below. All right, now if I split this problem up, I know that I've got 2 times y squared times 2 times y to the 5th, excuse me, times 2 times y squared. And we know that both of these 2's also have an exponent. Every number has an exponent. Their exponent just happens to be 1. It's 2 to the 1st power is that whole number, which gives me 2. So if I rewrite this, I've got 2 times 2. All right, and that gets rid of these. Then I've got y to the 5th power. All right, so there's 5 of them. Then I got another y squared, so I got another 2 over here. And so I just look at, really, this is 2 to the 2nd power here. And then this part right here, 1, 2, 3, 4, 5, 6, 7, this is like saying y to the 7th power. So your answer is either 2 squared y to the 7th, or you can think about it as 2 squared is 2 times 2 is 4, and y to the 7th power. And that would be the most simple way that we could write that. Okay, so now let's think about, all right, maybe I've got something else besides just the x in the parentheses like I have up here. Now I get an x squared that's in parentheses. And this is all raised to, this x squared is raised to the fourth power. All right, and so we know that the fourth power means I'm taking whatever I have and I'm multiplying it by itself a total of 4 times. All right, well, the thing that's being multiplied by itself here happens to be an x squared. So here we have x squared times x squared times x squared times another x squared, a fourth x squared. Okay, and then if we even split that up even further, you've got x times x times another x times x times another x times x times another x times x. Okay, and if we finally get that and think about how many total x's am I going to have, all right, we see that we would have x to the 8th power. Okay, so moving on, let's look at another example. So kind of getting more complicated as we go. I've got 4x squared y to the 3rd power. All that's in parentheses, and it's raised to the 3rd power. All right, and so that automatically tells us that this whole jumble of stuff is going to be multiplied by itself a total of 3 times. And so the junk that goes inside here, all right, is the same exact thing every single time. Okay, 4x squared y to the 3rd. Okay, and so then we got to think about what we have here. Okay, and we look and we see that this is like 4 times x times x times y times y times y. All right, this next portion is again another 4 times x times x times y times y times y, because there's y to the 3rd power. And then the last one is another 4 times x times x times y times y times y. All right, and so then again it goes to a kind of grouping of sorts, and we're looking at, all right, what pieces do we have? Well, I see I've got 4 and I've got 3 of those, so that's like saying 4 to the 3rd power. Okay, how many x's total? I've got 2 here, another 2, another 2, and that gives me a total of 6 x's, so that's x to the 6th power. All right, and then the y's, so I got 3 here, and 3 here, and that gives me a total of 3, 6, and 9, so y to the 9th power. All right, so we could leave our answer like this, all right, or we could think about what is 4 times 4 times 4, 4 to the 3rd power, so 4 times 4 is 16, 16 times 4 is 64, x to the 6th, y to the 9th power. All right, and then we would be finished with that problem. All right, so now what I've got is I kind of do a little bit more fun. So let's see if we can apply this concept to just some shapes. So something that doesn't have numbers in it, all right, we only have shapes. I've got triangle, square raised to the 3rd, circle raised to the 4th, and all that's raised to the 2nd power. So just in general, we have that, we know that this is going to be written out twice. Okay, and so what do we have? We have triangle, square to the 3rd, circle to the 4th, then another triangle, square to the 3rd, circle to the 4th. All right, and so we just kind of group up what we have here. Well, I noticed that I have triangle to the 1st and triangle to the 1st, so I have a total of triangle to the 2nd power. All right, and then I have square to the 3rd, square to the 3rd. So that would be like 3 of them. 1, 2, 3, 1, 2, 3. That's going to give me square to the 6th power. All right, again here, I got 4 circles. 2, 3, 4. Another 1, 2, 3, 4. All right, that's going to give me circle to the 8th power. All right, then that would be the final answer for this problem. Okay, so we've answered the question of like multiplying when something's in parentheses. And we just kind of look at, there are some patterns that emerge to our problems. Okay, again, now let's look at, let's say instead of multiplying with our exponents, like I'm multiplying x to the 3rd times x to the 5th, what if I have division? And so we know division is like the opposite of the multiplication. And so we're going to use that idea of writing these exponents out, or writing what they mean out, why they are what they are. And that's going to help us figure this out. So we know that this line right here, that means the division sign, right? So let's look at x squared. That is really x times x. Okay, and then x to the fifth power, that's x times x times x times x times x. We got 5 times. Okay, one thing that we notice is we know that we can cancel out a couple of these things. So one of these sets of x's and another set of these x's, those will cancel. All right, and it looks like everything on the top has canceled. Okay, and when that happens, there's an understood 1 that is left in the top of that fraction, or the top of that division problem. And so we have 1 over x times x times x. All right, and then instead of just leaving it like that, it kind of looks a little weird, we can write it the short way, which is x to the third power. So that's 1 over x to the third power. Okay, let's move on to another example. Well, what if there's more x's in the top instead of more x's in the bottom? Well, again, this is going to be x times x times x all over just 1x. All right, and we see that one set of those will cancel each other out, all right, and leave 1 in the bottom. So we have x times x over 1, all right, which could also be written as x squared over 1, or you could just leave that as just x squared, just kind of like we can leave 2 over 1 as just 2. Okay, and then lastly, we're going to look at our last example here, okay, x squared times y to the fifth all over x to the sixth times y to the third. And again, we're going to write these things out the long way. So x squared is x times x. Y to the fifth is y times y times y times y times y. All right, 5 times. And then on the bottom, we have x to the sixth. So I'm going to write these x's 6 times. All right, and then my y is 3 times. Okay? And then I'm going to go through and I'm going to say, all right, well, what can match, what can cancel each other out? All right, I'm actually going to do that in the red pen. All right, so one set of x's cancels, another set of x's cancels. That leaves me with no x's in the top, all right, but some in the bottom here. And then I think about my y's. All right, one set of y's cancels, 2 sets of y's will cancel, and 3 sets of y's will cancel each other out. And I see that I'm left with 2 y's in the top of my fraction. So when I go to simplify this, instead of leaving it as y times y over x times x times x times x, all right, we can write that as y squared over x to the 4th power. All right, and that's the simplest way that we can leave this. Okay, so I want you to think about, all right, as we go through, think about a rule that would help you with solving these problems. So think about the different types and see for each of them, can you think of an easy rule or maybe a shortcut that would help you out instead of having to write these out every time. So is there a rule or is there a shortcut? Maybe kind of jot down some ideas that you would have.